Welcome to iLecture Online, and here's a new topic in physics for us, fluid statics. And then of course after this we're also going to talk about fluid dynamics. The difference between statics and dynamics is statics that everything is stationary, no fluid is moving, anything like that. Later on we'll have fluid that's moving, and that's a slightly different part of physics. But let's start with the easy part first. Everything is static, is motionless, and the first topic in that is trying to find the pressure in a fluid. So we're trying to find the pressure somewhere in the fluid, and to make it easy, here we have kind of like a pool. We want to know what the pressure is at the bottom of the pool at a depth of h below the surface. And in fluid statics, we always think about downward as the positive y direction. So the deeper you go, the greater the value for y. And of course, the definition of pressure, that's equal to the force divided by the area. So what we have here is we have an imaginary column of water that's resting on the bottom of the pool. So the surface area right here, area, is simply equal to the width times the length of that region. So that's A times B. And the force would simply be the weight of the water column on top of the bottom of the pool. So force is equal to the weight, and the area is equal to the product of the two sides at the bottom of that water column. And of course, the weight of the water is equal to the mass times the acceleration due to gravity. So this can be written as mg divided by A times B. All right, now, in fluids, we have a relationship between the mass and the density. And that relationship is that the density of any fluid is equal to the mass divided by the volume, which means that we can solve this equation for mass and write that the mass is equal to the density times the volume, and substitute that in here for our equation for the pressure. So that means that now the pressure can be written as the density of the fluid times the volume times G divided by A times B. Excuse me. So the volume means the volume of this water column, and the area underneath is simply still A times B. Now of course the volume of a cube is equal to this area of the base times the height. So this can be written as the density times the area of the base, which is A times B, times the height, which is H, times G. So volume is replaced by this, divide this by A times B, and then right away, of course, you can see that A and B cancels out. With other words, it's per unit area, that gets canceled out. And then since the height of the column is equal to the depth of the pool, we can then replace H by Y, and so this can now be written as the density times Y times G. And then finally, the equation we like to use, we like to rearrange those terms and write it as the pressure at the bottom of the pool, which is really the pressure at any depth y, can be written as rho g y. And that's the equation we use to find the pressure inside the liquid. Now, as an example, let's say that this is water, and therefore the density is equal to 1,000 kilograms per cubic meter. Let's say that the pool has a depth of 2.4 meters. That means that y is equal to 2.4 meters. And let's see, what else do we need? G, we know what G is. That's 9.8 meters per second square. So in this case, the pressure, when we assume that the density is 1,000 kilograms per cubic meter and the depth of the pool is 2.4 meters, that is equal to the density, 1,000 kilograms per cubic meter, multiplied times G, which is 9.8 meters per second squared. Multiply that times Y, which is 2.4 meters. And notice then that the pressure is going to be, and let me grab my calculator, 1,000 times 9.8 times 2.4, and we get 23,520. Now what are the units? Well, kilograms meters per second square, that's the units of force, that's newtons. And then we still have a meters and a meters cube here, so this meters cancel out one of those. Now we have per meter squared. So the units then become newtons per meter squared, and we have a new unit for that. That is equal to 23,520 pascals. Now, how much pressure is that? Looks like a big number. But if we compare that to atmospheric pressure, which is the pressure caused by the atmosphere, which is known to be P atmosphere, is equal to 101,300 newtons per square meter or pascals, then you can see that this is just a fraction of a little bit less than 25%. So let's figure out what fraction of atmospheric pressure it is. So P divided by P atmosphere is equal to 23,520 pascals divided by atmospheric pressure, which is 101,300 pascals. So if we do that, divided by 101,300, we can see that this is equal to 0.23 or 23% of atmospheric pressure, which means when you dive into a pool and you swim to the bottom of the pool, and let's say the pool is about 2.4 meters deep, then you experience the pressure of about 23% of atmospheric pressure. Okay? And that's how you find the pressure inside any fluid at any depth, knowing the density of the fluid, and of course, being on the Earth, G is 9.8 meters per second squared.